Good morning, everyone. So let's get started. Uh, let's have a very quick recap of EC, and you'll notice most part is quite mathematical. So once we had defined average current follows the definition of any quantity average velocity, average acceleration. So when we define average for any time interval, this is a typical definition for average and similar to what we have for average velocity. And the same thing can apply for average voltage also. Suppose the question is calculate average voltage, and if voltage is varying with time, so which means if voltage is given as a function of time, if we have to find average voltage between two instances of time, T1 and T2, this would be the expression for any average function, any average physical quantity. For current would be like this. Similarly, we can have similar expression for voltage as well. Then we define something like IRMS. And IRMS, the word why by use square, mean, and root. That's what we do. Since IRMS is to find the constant current, will produce same average power. And power in a resistance varies as a square of current. That's why what we do, we take the average of not current. We take the average of square of the current. This whole term is average of a square of the current, and then we take a square root. We square it, take its mean, and then take the square root. And for current, which is varying as a sine function, IRMS comes equal to maximum value of current divided by root 2. So this is something, unless it is stated otherwise, whenever we refer to IRMS, it means it is for a time interval equal to time period. That's IRMS. And for sinusoidal function, Im by root 2. But okay, and here also to understand why do we come to this particular expression, this IRMS square is this value. What is this term here? If you look at the whole thing, this term is similar to this term here. This whole term is average of square of current. And power consumption is proportional to square of current. That's why it makes sense. And then to find IRMS, we take a square root. And sometimes this understanding is helpful in solving certain questions better. So far all mathematical expressions, and you'll notice all are definite integrals. And some cases when we talk about IRMS, it can also be find IRMS for a particular time interval. So IRMS, if not stated otherwise, it is for a time period which is equal to long time interval. And it can also, some question they can say find IRMS between time T1 and T2. In case if it is T1 and T2, rather than taking 0 to capital T, we'll take whatever time is given here. This also perm. So this is for a specific time interval. And all are definite integrals. So as far as finding these values are concerned, they're all simple definite integrals. There's not much of physics, simple mathematics, definite integrals. So let's go through some simple applications of the same. Okay. Let's look at this some few questions. Average current of a, and this is a question given. Initial phase is 0. And find average current from what time to what time. Find average current from T is equal to T by 8 to T by 4. That's what we need to find. And initial phase is 0. Okay, so if we have to draw this current initial phase is 0. Sorry, so this will be, the shape will be, current will be like this. T is the time period. So this is pretty simple question. If you have to find I average, this particular case is not for the entire time interval. Simply we can use the formula. What would the formula be? So we'll find area under the curve from where to where, from T by 8 to T by 4. So this is from where to where. I have to find average between T by 4, T by 8 to T by 4. And what will the current value be equal to? If I have to write current here, current peak value is 5. Sine of omega, in place of omega, I can write this term. And phase constant is 0, since initial phase is 0. This is the value of I. So here also to find average, I write the value of I dt. And this will be from T2 to T1. T2 minus T1, T by 4 minus T by 8. And we substitute this expression. It's fairly easy. It becomes T by 8, T by 8 to T by 4. And we substitute the value of I, 5 sine of 2 pi by T into capital T. It's a simple integration, and Okay, so we can easily find the value. And this comes to 10 by pi into root. So it could be for any other time. So in terms of the figure, if you look at what is this? This is a from here to here. This value is t by 4. Sorry, this value is, yeah, this is t by 4 and this is t by 8. So what does this average current signify? That this is t by 4 and this is t by 8. Average current, this is the this entire expression indicates the area here. If I divide this area by this delta x here, something like this would be my average current for this interval. So this is a simple definite integration. What is the average current for t by 2? And all you can easily calculate. Okay. So suppose you have to calculate average current for t by 2. I think yesterday you calculated. Average current for t by 2 comes equal to 2I by pi. That's value of average current for t by 2. If I take average from here to here, and this is the value. So suppose for average current for t by 2 is equal to 2I by pi. What is the average current from t by 2 to capital T?
Be the same.
Yeah, let me ask some more people. So this is the average current from where to where? This is average current. The moment you say average current for t by 2, it is implied from 0 to t by 2. So this is you can very simple integration. It comes 2I by pi. So what would be the average current from t by 2 to t? So this I have given average current from 0 to t by 2. What is the average current from t by 2 to t? What is the average current? Hemant, can you tell what is the average current from here to here?
It would be the same, sir.
Will it be same? There's some difference here. Can you think of what is the difference here? See, when we take area, this is positive, what would this be?
Negative, yeah.
Negative. So when we take average current for t by 2 to t, and that's the region, let's say we'll come to the second part here. So we have to take care of whatever, if this is taken as positive, other will come negative. So this average, yes, it is, we don't have to, easily we can figure out, this would be the average current. So basically whatever current flows here, for 0 to t by 2, the average may be something like this. If I have to show the average, average current from 0 to t by 2 is something like this. And average current from t by 2 to t will be like this. Now, if I extend this question further, if I ask what is the average current 0 to t? Now, this is, see, those time intervals are equal and values are also equal in magnitude, opposite in direction. So when I take average of these two quantities, this becomes equal to 0. So what is the average current 0 to t? This becomes 0. Yeah, because both have equal weight, both have an equal time interval. Something similar to average velocity is something going in one direction, coming back. What is the average velocity when an object goes from A to B and it comes back from B to A? It becomes 0. Now let me ask something. What will the average current from 0 to 5t by 4? Can we calculate what will the average? And so, okay, let me ask one more thing. This we have tell average current from 0 to t by 2 is 2I by pi. What will be average current from 0 to t by 4? I have written 0 to t by 2. What will the average current 0 to t by 4? Okay, Jaideep, can you tell me what will the average current 0 to t by 4?
I by pi, sir. Or we can substitute in the formula.
I know you can do substitution. See, reason I'm taking it up because substitution is one thing, but there's something called common sense also, and understanding the sense of average value. So average value 0 to t by 2. I have already written this expression. Now I'm asking what is the average between 0 to t by 4?
I by pi.
You say it is I by pi. Okay. Disha, what will be the average between 0 to t by 4?
2I by pi.
2I by pi. Why would it be 2I by pi?
So because the time period is also half and the area is also half.
Yes, basically what is happening here, the area is becoming double and time also becoming, yeah, so time area also half and time also half. Jaideep, are you following?
Yes, sir.
So t by 4 also, whatever average we have, next t by 4 also average is same. That's why average between first t by 4, second t by 4 and t by 2, all three are same, which is equal to 2I by pi. Now if I ask you, you can always do integration, but can you tell me what will the average current from 0 to 5 t by 4?
2I by
Without
pi.
integration, can someone tell me what would be the average current from 0 to 5 t by 4?
2I by pi.
Hmm? So see, here also I can divide in two intervals. What are time interval? 0 to t and t to 5t by 4. What would this value be? Will it be related to this value somehow? Yes, Vignesh, you were saying something. What would be the
Will be
average
same,
current?
sir.
Huh?
Same as this.
Same.
2I by pi.
The time interval is different.
Can you say, can someone think and tell? Already written t by 4, it is how much? T by 4 is 2I by pi. What will be the average from 0 to 5t by 4?
2I by 5 pi.
2I by 5 pi. Excellent. Who said Ahlad? Huh? Ahlad, you said, huh?
Yes, sir.
Tell me how.
I mean, if
What is saying? It is
pi
saying
time interval.
2I by pi into 1 by 5. And rest of you also think why it is so. Because this is something not integration, not substitution. This is intuitive understanding, and this is understanding what I think is this is something you should develop. You should actually, this should be developed in the school itself. If you're not, make an effort and try and understand why it is so. Except, how did you figure it out? Did you do any calculation, or you can intuitively work it out? This will be like this.
Sir, it's not AvgRMS, so we can't just see the magnitude.
Okay, so some rest of you also can think. I'm that yes, you can do by integration, but think of it. How do we get this value? And if I extend it further, what will the average current from 0 to 4n plus 1 t by 4 if value of n is large? Can anyone think and tell me what will the average current from 0 to this time interval if n value is large without any integration?
0.
It will be 0. Because this thing, you can answer this question based on your understanding of concept of average, not based on integration. Jaideep, are you following what I'm saying now?
Yes, sir.
So basically, if some part is we can solve, rest of it, see, this topic is, most of things are mathematical, but certain things you can solve mathematically. It is even better if you develop an understanding of what does average mean. Okay, and this term very good. Some of you can figure it out. It is 0. Those who are not figured out, try and understand why it will approach 0. So average current, and what are this indicate? Yes, so this will indicate it will come to 0. Okay, and okay, and you can think of this reason. So all of you can try. So those who are not able to understand right now, and if you want to improve your understanding of average, think of answer for these two questions. Think of this answer. Okay, let's look at this question. This question also is again a simple question, and you can solve mathematically, and you can also solve without any integration. So read the question. Can someone give an answer without any calculation? I is varying like this. I is not, the phase is not, the phase constant is not 0. What is the phase constant here? If I take 2 pi by 4, phase constant is equal to pi by 2. If phase constant is pi by 2, if I draw the I curve, it is starting from maximum value, maximum positive value. This is how I is varying. We have to find what is the average current in first quarter time period. Okay, what is the average current in first quarter time period? Preetham, can you tell me what will the average current between first quarter time period?
Like using the formula we can do.
Yeah, if you have to use formula, how would I have done average value? I would have done using the formula. I would have used something the same formula, T2 minus T1, and I can write the expression for I, sine of 2 pi. You can use the formula. Okay. In that case, what I'll substitute here, this part will be T1 and T2. So in this case, what will substitute here in place of T1 and T2? I'll substitute 0 and T by 4. Okay, I can do that 1 quarter. But we had done something previously. Previous slide we had done something. We mentioned that for this period, for this area, what is the average value, Preetham? Here we did something. What is the average value?
2i by pi.
So can you use, do we have to redo this integration, or can I give this answer without any calculation?
We can give say without calculation.
What is the answer? This also will be equal to 2i.
It will be 2i by pi only.
2i by pi. And this something, it can be integrated. I'm not saying it cannot be integrated. It's not a difficult integration. But if you understand, this gives you better understanding. This is an answer based on much better understanding. This is step-by-step method. Nothing wrong with this. I'm not saying this is not wrong. Most of you can do that one. But in addition, if you can understand why it is so. Because I draw this curve. It's nothing I notice. What is this is 0 and this is t by 4. I already know whenever I have a quarter of the sine curve, the average of the quarter of the sine curve is twice the maximum value divided by pi. So this also average will be same. I don't have to redo the whole thing. Okay. This is a little more complex. What should be the value of phase constant? Here the phase constant was pi by 2. What should the value of phase constant for average current in first quarter time period to be maximum? Okay, so this is a kind of question I will not answer now. All of it, this is kind of food for thought kind of thing. Think it over, how to get an answer for this. Okay, is this question clear? Nitya, have you understood what the question is?
Yes, sir.
This is phase constant. So this is something I'm taking this as a variable. What should be the phase constant here? What should be the value of phase constant so that average current for first 1 quarter time period to be maximum? Can the okay? So this is something you can, all of you can think. And when we have evening session, I would like to hear from some of you. How do you get an answer for this?
It is pi by 4, right?
Excellent. It is pi by 4. And it's something if you understand, very quickly get it. An excellent, very good answer. It will be pi by 4. Okay. Now coming back to more simpler question, alternating current signal is given like this. This question is fairly simple. What is the time taken for current to rise to 0 to RMS value? And what is RMS value? So in this case, what is the initial phase? Initial phase is 0. So what we notice here, phase constant is 0 here. So if I have to visualize this curve will be like this. This is how the curve is, and this is the maximum value. So what is the time it will take to rise from 0 to RMS value? What are the RMS value corresponds to? RMS value is equal to maximum value divided by √2. For all sinusoidal function, RMS value is taken as for time period or long time duration. And I0 by √2, so this corresponds to what will the phase corresponding to this? This corresponds to, this is phase 0. This corresponds to I by √2 corresponds to phase angle of 45 degree or T by 8. So time taken for current to change from here to here, I can solve mathematically. What is mathematically I solve? I'll say let the time be t, then I will be equal to, in place of I be equal to, let the time be t, let time t. So at time t, what has to value of current? If the current becomes equal to RMS value, it will be maximum value of current divided by √2 is equal to I0 sine of 2 pi n. Basically, what does n indicate? N indicates frequency here. I can find out value of time here. Then basically from here I can find out. But if I understand phasor diagram also, the time taken to rise from 0 to RMS value will be equal to T by 8. And is the frequency is given to frequency is n. So time period is 1 by n. So what is the time it will take? 1 by n by 8. That's the time it will take. Okay, if I add one more question here. See, can we answer this question? Okay. What is the time interval when current is greater than RMS current during 0 to t. For what duration is the current greater than RMS current? What will the duration of current between 0 to t? The current will be greater than RMS value. So when the current is greater than RMS value, the power consumption is greater than average power consumption. When current is less than RMS current, power consumption is less than average power consumption. Okay. Karthikeya?
Yes, sir.
Have you understood what I said now?
Not entirely, sir.
Huh?
Not completely.
Okay, somehow you're not so well audible. Okay. So what duration will the current be greater than RMS current? Ashray, can you answer this?
T by 8 to T by 4, sir.
So when you look at this, is it a difficult question to answer? Time interval current is greater than RMS. What is RMS? This is the peak value of current. And RMS current is equal to this divided by root 2, which is roughly 0.57. So I naught by root 2. And this is the interval when the current is greater. So here, power consumption, instantaneous power will be greater than average rate of power consumption. And again, from here to here also, from here to here. So this is the period, this is the time when current is greater than, magnitude of current is greater than RMS current. And this is the time when power consumption is greater than average power consumption, and rest of the period is less than this period. What is time? This is time interval from here to here. And what is this time interval from here to here? This will be equal to, how much this will be equal to? T by 4, and this also T by 4. So what is the time interval when the current is greater than RMS current in 0 to 2? Total time interval is T by 2. So half the period power consumption is less than the average, and other half the period power consumption is greater than average power consumption. Okay. Bhageshri?
Yes, sir.
Is this understood?
Yes, sir.
Okay. Average power consumption. Okay. Now, what we had done, yesterday we had done RMS current for the entire time period for sinusoidal function. What if the current is given like this? See, the current is this current periodic? So we have RMS value of current. We typically do it for periodic currents. Okay. So here also, if I say find RMS value of current, it itself implies I have to find RMS value for what duration? For 0 to t. So whenever it is not mentioned, if it is not mentioned, it is understood it is for 0 to t. Can I find value of RMS current for 0 to t? How do you find out current from 0 to t here? Kaushik, can you find out how do you find RMS current here? Kaushik?
Yes, sir.
Can you find out RMS current here in this case? What we need to do?
So we need to like integrate all this square of the current. We need to
Square.
find the function.
So basically, very good. So basically, first thing, this is when we talk about RMS current, it is simple mathematics. So first of all, you need to know what is the RMS. You have to square the current. Basically, what is this equal to? This is what it is equal to. Only thing what I need to do, only thing I have to write I as function of time. If I can write I as in terms of as a function of time t, and this graph is given. So whenever graph is given, we can always convert. This is I here on the y-axis as a function of time. This is t. So can we write I as a function of time? It's fairly easy to write from here to here. This is straight line. So what is this equation line like? This equation relationship is similar to y is equal to mx. Only thing in place. In place of y, we'll write I. In place of x, we write t. What is the slope equal to here? Slope is equal to Im by t.
Im by t, sir.
And t, that's the equation. So finding RMS current is fairly easy. So what will be RMS value of current? That will be equal to, or we can write as square first and then we can find. Because I think to me RMS square makes more sense. Is average of the square of the current. So what this be equal to 1 by t, and that's very simple integration. Im square t square dt, and that becomes Rms square t cube into t cube by 3, which is equal to Im square by 3. Or what is IRMS equal to? IRMS Im by root 3. This is fairly simple. Okay, let's look at some variation, and what we find interesting here, this term is independent of t. Has the t term come here? So in place of t, this would have been 2t. 2t also had the slope been different. See, it has come independent of t, means it is independent of slope. It is independent of slope. So as long as it only depends on what is the maximum value it reaches. Okay. So let's look at some variations here. This part was fairly simple. What if curve is something like this? What will the RMS value here? What will the RMS value? We have found the RMS value for the above curve, A curve. Now for this shape, what will the RMS value?
It is the same.
Why?
Maximum value is same, right?
Well, see, basically it is like area under the curve. When you square it and take the area, when I flip a curve, the area does not change. Okay, so here also it is something, but it's the same curve has been flipped over. And if you want, you can you write an I as a function of time here? How would I have written I as a function of time? This equation becomes equal to y is equal to mx plus c. And I could have written that equation, I could have gone to the integration. But if we do integration also, I'll find the value will come same. What will I be equal to? Slope is negative. So it becomes equal to minus Im by t into t plus Im. And again, if I do integration, but without doing integration also, I easily notice this is something when I take this curve area, and if I flip over the curve and make it this side also, the area remains same. And similarly, area of the square of the curve also will remain same. So this also will come same. This also will come equal to I naught by, sorry, I maximum by root 3. Okay. And you can try. Some of them you can check, but you can substitute this also. We'll find both values are same. What is the value of RMS current here? First case this. Preetham, what do you think will be the RMS current here? Can we figure out what will be the RMS value of current here? Is this periodic? Yes, it is periodic.
It is the same, sir, as Im by root 3.
Why?
Because it's the same area under the curve.
Okay, I'll ask another question now. See, suppose a current is like this. If between time period, rather than varying like this, the current is something like this. It is 0 to t by 2, value is A, and between t by 2 to t, value is B. The RMS value, what will be RMS value in this case? How do you calculate RMS value? You can calculate RMS value like this, 0 to t and t. This is first case. And second case, if A is equal to B, then what will be the RMS value? Current is given like this. If A is equal to B, then what will be the value of IRMS?
A.
A only. So if two intervals are there, if both the intervals RMS values are same, the complete interval also RMS value will be same. Now look at this curve. I've already done this one. If any shape is like this, is RMS value is equal to what? This part RMS value is equal to Im by root 3. Now look at the right part also. What is the RMS value for this part of the curve? This also earlier also, this also is equal to Im by root 3. So what will happen, since both the time, this time interval and this time interval, these values are equal, for the entire time interval also will be same as Im by root 3. So this is the first case. Now this case and this case similar. What is the difference between the two? Disha, what do you think will be the IRMS value for this case here?
1 second.
Think and tell. You can calculate, but you do actually, when you do calculation, it become time consuming. But again, it's not so easy to integrate. It will take 3-4 minutes. Taking a little time. Nitya, can you tell me what will be the value of IRMS here in this case? Not clear?
No, sir.
Okay. Abhirup, can you tell me what will be the IRMS in this case? Abhirup?
Yes, sir.
Can you tell me what will be IRMS in this case? This case,
The
have
same, right?
you followed what I said about this?
Yes, sir. If both the intervals are the same.
The same, then I can overall also be same. It makes very simple common sense. So what will the, can I do? Can I arrive at IRMS for this kind of shape without any integration?
Will be the same, right, sir?
Why?
Because it doesn't depend on the time period.
Doesn't depend on the slope. Sir.
Yeah, slope basically.
Same here. First of all, let me take 0 to t by 3. If I take this time interval is similar to integration I have already done in the previous sheet. I have done this case also, I have done this case also. If I have done both cases, in both cases I have found it is equal to peak value divided by root 3. I take two time intervals. I take first this time interval. What will be the value of IRMS current here? From here to here, IRMS current will be equal to max value in this interval divided by root 3. Similarly, now the second time interval, I have to find for total time interval t. Now for other time interval also is again a straight line. If it is straight line, what will the IRMS value from here to here for this time interval? This is second time interval. It is equal to 2t by 3. Here also it will be the peak value divided by root 3. Because here also it is going from peak to 0. So what will the IRMS here? This also will be equal to I max by root 3. And since two are equal, for entire time interval also it will be equal to Im by root 3. Nitya, is this clear?
Yes, sir.
Does it sound complicated?
No.
It's a fairly simple logic, and this also both will be equal to this. Rest of the people following. Anvita, have you understood this?
Sir, can you please repeat it, sir?
Okay, so let me explain some other way also. Okay, let me do some, let me take a little more time on this. Okay, so maybe some of you are not so clear. So let's repeat that part. Suppose I have something like this. Let me change this question a little bit. This value is, this is current is given like this, and this is here the time is, and this is equal to t by 3. This current is equal to I, and from Anvita, can you calculate what will be IRMS from 0 to t here for this shape here? Anvita, can you calculate for IRMS from 0 to t here? Now this question is not physics at all. This part is simple mathematics. What will be the value of IRMS here? See, all of you try. Can you all calculate what will be the value of IRMS if the current is getting like this and from 0 to t? Can we calculate IRMS here? What is IRMS definition? If I go for, I'll calculate many times. If you want to square root, first we'll calculate IRMS square, which is equal to 0 by t, 0 to t, I square dt. Anvita, can you calculate this term here?
Sir, I'm doing it, sir.
Tell me about how, is any difficulty in this?
No, sir.
No problem. We can do that. But basically what you have to do now, since pi is not, we have to divide into two intervals. One interval from 0 to t by 3. And in that case, I will write I square dt. And second case, I am writing 0, t by 3 to t. In that case, I naught by 2 square dt. Okay. and it's a fairly simple, easy integration. There's no integration actually. I can easily calculate IRMS square. It comes equal to I square into T by 3 plus I square by 4 into 2T by 3. And this is pretty simple that all of you can easily find. Yeah, and this is easy understood. Dhanshri, have you followed this so far?
Sir?
Yes.
Sir, for the one on the right, sir, can we do it purely using area, sir, instead of integration?
Actually, we have to square of the area. See what I could have done. I could have taken area. I would have taken mean area. In that case, what I need to do, I need to do I square and I naught by 2 square. See, it is not area, square of the area. Are you following what I'm saying now?
Yes.
Okay. So we can find. Kevin?
Yes, sir.
Have you followed this?
Yes, sir, I have followed.
This is easy now. So far we have taken what kind of things? We have applied this definition to 2-3 different types of cases. What are the cases? Every time what are we doing? We are expressing I as a function of time. One case initially started with the sine function. We are also taken a straight line function, and we are also taking this also nothing but a straight line. But a straight line is 2 different segments, so we have to take 2 different time intervals. We can easily find. Is this easy to understand so far? Now, Kevin, you tell me one thing. If I take second case is like this. How much this comes to? This comes equal to I square 1 by 3 plus 1 by 6. Sorry, I square. Okay, T gets cancelled. This IRMS. Now, Kevin, you answer me this time. Current is like this. What will be the IRMS value in this case here? B question. What would be the IRMS in this case? How long will it take to calculate? Kevin, are you listening?
Yes, sir.
Can you give me the answer for this one? Have you understood previous one?
Sir, is it the same as the previous one?
It is same as the previous one. The answer will come same. It doesn't end up sign, doesn't matter. When you square it, becomes same. So this also answer will be same. Okay. Now I come to third one, even simpler than this. What is the third one? Third one is like this. Again, 2 time intervals, T by 3 and T. Okay. So in this case also up to T by 3, it's equal to I. And the remaining part also it is equal to I. What is the RMS value of current here? Will it be not I equal to I itself? So this becomes this becomes equal to constant current. Anvita, so is this clear? A, B, C, all parts are clear?
Yes, sir.
Okay. Now coming to this question. So basically what we do, coming to this question, so when we talk about this I naught by root 2, what does it mean? It means rather than having a current like this, I can have a constant current equal to I by root 2, right from 0 to T, and it will produce the same power. That's what it means. Is it not? I can replace these 2 currents which have 2 different values by a current which is constant all through the time interval T. If I maintain this current, it will produce same power in the resistor as these 2 is this current is producing in the same time interval. Anvita, what did I say? Have you understood this? Can you repeat what I said? What does this red line indicate? Are you clear about this part?
Not really, sir.
Not clear? Okay.
No.
Okay. Let me ask someone who's clear. Kartikeya, have you understood this part here?
Yes, sir.
Have you understood?
Yes, sir.
Okay, but your voice is not clear, so clear. So let me ask somebody else. Okay, Bhagishri, have you understood this part?
Yes, sir.
Can you explain what he said just now?
If we can replace the both currents by an equivalent current one.
So because what is happening, current during time interval t, current is not constant. It has some value I between 0 to t by 3. It has a different value between t by 3 to t. So when the current is not varying, it has two different values. We find difficult to understand. So what you say here, what is the constant current I can maintain, which will produce same power consumption as this current, which is not constant. So that's what RMS mean. So as far as power consumption is concerned, these two black lines I can replace with the red line. Anvita, are you following so far?
Yes, sir.
So it's like this what concept of equivalent mean. The concept of equivalent means the things which are two different values and it's a little more complex. I can replace with something which is constant, which is uniform, which makes it easy. I can replace with this. Now coming to this question here. So first here, from here to here, how's the current like? This is T by 2. I can replace this part of current. This current is varying. Can I replace with a constant current for purpose of calculation of power? What constant value of current I can replace it with? I can replace with the RMS value, which is equal to Im by root 3. This is for first, between 0 to T by 2. How about T by 2 to T? Here also maximum value is Im and dropping to 0, linearly varying. This also I can replace with the constant current here. And this case becomes equal to the previous one. So our entire duration becomes equal to Im by root 3. And same concept is applicable in this case as well. Shreya?
Yes, sir.
Have you understood?
Yes, sir. Now I've understood.
Now clear? Okay. Anvita, is this clear now?
So like in the B graph,
B part.
sir.
And also B part also. Let's say this also is T by 3. So here also it was T by 3. See why this case and this case. Can I replace with a constant line? So here first T by 3. What is the value of current? This is equal to Im by root 3. And what will the RMS value between T by 3 to T? This also max value is same. This is 0. I get this part also. Just forget the left half of the left part. If I look only in the right part, this varying current I can replace with a constant current equal to IRMS, and both will give same power. What will this value be equal to? Peak divided by root 2. The P divided by root 3. So this also is Im by root 3. This also Im by root 3. What is what total duration? Im by root 3. Is it clear now?
Yes, sir.
Okay. And briefly, yesterday we also spent little bit time on, see, just pay attention to this part, all of you. And this also is important part of this. See, when we apply Ohm's law, in case of DC, it is easy. There's only one steady current. There's one steady EMF. Here we have briefly mentioned yesterday, current as well as voltage can be expressed in three forms. What are those three forms? So when I look at this also, see, this is the current curve here. Current curve here is something, if I look at what does this represent here? This represents instantaneous value of current. There is something called instantaneous value of current which will keep varying. It may change its direction also. And typically what we do, instantaneous value of current we represent by I small. There's something called maximum amplitude of current, the maximum value the current reaches in case of sine wave. That we can amplitude of current we represent by Im. And the third is IRMS. IRMS is we take this, we also call it RMS current. We also use the word sometimes apparent current. Apparent current means though the current is varying, it will appear to be equivalent to RMS current having a constant value. And this RMS current, either I can represent IRMS, or sometimes many times we also represent as capital I. So capital I represents RMS value of current. So it is RMS current. These are three notations we use. Same thing applies in case of voltage also. Voltage also, the three terms, if I write small v indicate instantaneous value. Vm indicates amplitude of voltage. And if I write capital V or VRMS, it represents RMS value. And RMS value for sinusoidal function is equal to, that also be equal to Vm by root 2. Okay, and these things are nothing because of the, so when we come to application of Ohm's law, Ohm's law, okay, this VRMS, this is something you need to remember. Now, Ohm's law, at instance, we apply at an instance, V is equal to instantaneous value of I into R. So either we apply Ohm's law to current and voltage at an instance across the resistance. This is valid. Both sides, V and I, both are instantaneous values. It is also valid at the peak. Since it is valid at all instances, it is also applicable when it reaches its peak. So when we can apply amplitude of voltage also related to amplitude of current like this. So here also, if in this case, both the terms have to be similar. If this one instantaneous value, other also has to be instantaneous value. If one is peak, other also is peak. And if I divide by √2, it becomes RMS value. So V is equal to IR. So all three forms, but we can't mix it up. We cannot write V is equal to IR. We can write both value, either both have to be instantaneous value, both have to be peak value, or both have to be RMS value. And it comes, other two comes from the first equation itself. Okay, so that's a small thing we need to keep in mind. And okay, and unless specified, whenever they use AC voltage of 220 volts. So anytime when we state, actually that refers to RMS value. So unless it is mentioned the peak value of current is 5 amperes, then only it is peak value. Otherwise, if current is 5 amperes in AC, it means RMS value. So unless it's specifically stated, or if written, if suppose V is written like 300 to 310 sine of 100 pi t. If it is written like this, naturally this term is peak value. So unless stated specifically, or it is in form of sine function, the value of current and voltage refers to RMS value. We'll come to more application, we'll see that later. This point also we have to keep in mind so that we don't get confused. So domestic supply, when we say 220 voltage, we refer to this term very often. Is that the peak value of voltage? No, that's RMS value. What is the peak value of voltage supply we get at home? That is 220 into √2. Peak value is √2 times the RMS value, or RMS value is 1 by √2 times of the peak value. And in case of, there's something called similar to DC voltmeter and ammeter. There's AC voltmeter and ammeter, and AC voltmeter and ammeter measures RMS value. It cannot measure instantaneous value. If you have a ammeter which measures instantaneous value of current, if the current is like this, what will happen? It will just keep dancing. And this vary too quickly. But the current is changing so rapidly in magnitude and direction also, it cannot show an instantaneous value. AC voltmeter and ammeter measures RMS value. So these are very simple points.
Galvanometer, sir.
Pardon me?
It doesn't use a galvanometer.
No, it has something. It's something. It works on heat generated. It doesn't work on the galvanometer principle. You understand why can't galvanometer work here?
Yes, sir. It'll keep fluctuating.
It'll keep fluctuating, and too often. But how many times? But this is something it completes 50 cycles in a second. So it will, but it will be too rapid, and we can't see anything happening. It will not settle down to any value.
So then, why doesn't
we use other principle, and that principle we don't discuss. But the principle works on based on heat generation. Okay, and so whenever we talk of AC voltmeter and ammeter, whenever it is connected, it will show RMS value. So if we connect a AC voltmeter, it will show RMS value of voltage across 2 points. If ammeter is connected in a branch, it will show the RMS value of current in that branch. Any question on this so far? This is simple and just stating some facts. This is not big concept here. So this is one point. So we don't get confused whether current is RMS value or peak value. So unless it is stated clearly or in form of equation, we have to assume it is RMS value, right? Let's look at some. I think some. We go to some of those questions. We practice a little more. It becomes more clear. First question. These are simple questions now. See, what is this 220 volts here? Is it RMS value or peak volt value?
RMS.
RMS value. 58 supply is connected to across a resistor of 50k ohms. The current at time t, assuming that it is 0t, and what is the current at time t? Can we answer this question? So this question is very simple. How will current vary as function of time? And of course, we know current as a time is equal to, it will be something like this, sine of omega t. And this omega will be same as EMF, and which is equal to, it will be equal to Im sine of, since frequency is given omega is equal to 2 pi f t. That's how the current will be. And let's put those values here. What will be the maximum value of current? What will be the amplitude of current? Amplitude of current, again, we can apply same Ohm's law, but corresponding value also has to be maximum voltage.
Root 2 into RMS.
This has to be Vm by R. So Vm is how much? Vm is not 220. Now Vm has to be equal to 220 into root 2 divided by R, which is, or we can say it is equal to 220 into root 2 divided by 50 milliamperes. And F value, substitute, this becomes 100 pi, this becomes 314. Okay. So whenever you see this one and we understand, so whenever we apply Ohm's law, whenever we write equation equal VIR, either we use RMS value, instantaneous value, all these two values have to be the same. Since I'm interested in finding max value, here corresponding V value also has to be maximum value. Yes, Akash?
Sir, when current is varying, so then like suppose a light bulb which should also flicker, right?
See, our eye cannot sense something which is changing too rapidly. Yeah.
So it always seems on.
Yeah, but see something. See, that's what the see. If there's an object here, if very rapidly this object is removed and placed back here, if it is done very quickly in less than say 1/20 seconds, your eye will not even notice it has disappeared.
Okay.
Okay. And and flickering is basically it is its brightness is changing. There's nothing called negative brightness. The current is oscillating, but yes, you can say so. And the brightness and typical bulb,
like it comes to zero also. Right?
But what happens? See, there also, what will happen? Will it constantly changing? It will reach to a particular temperature based on the heat. So radiation generated on the temperature will not vary that rapidly. Are you following that point?
Understood, sir.
Okay. So actually that's a little more complex. You think it over, you'll understand what I imply here. It will get heated, and the rate at which heat is getting added to that conductor is varying. But its temperature cannot change so rapidly. So its temperature will fluctuate in a very minor range. Okay. So this is different thing and this is different thing. So it will not fluctuate kind of thing. And fluctuation is so nominal, you can't notice it. Okay, this question. One case of DC voltage and 10 volts of DC voltage is applied to a resistor and it produces heat at the rate of X. So peak value, what is the peak value of AC voltage will produce heat equal to X by 2. So let's say what is the power in case of DC? This is something we assume the resistance is R. Can we easily solve this question? Let the resistance be R. Same resistor, let the resistor be R. So in case of power, in case of DC, is equal to V square by R. And that is equal to X. In case of AC, if voltage is V max, what is the average power consumption? In case of AC, average power consumption is VRMS square by R. Or I can write I can V is given, I can calculate IM. IM will be equal to VM by R. I can write V square by, I can write I square R. Both cases comes to same. It has to be VRMS square by R. VRMS will be equal to V max divided by root 2 square by R. And that is equal to how much? That is equal to X by 2. So VM square by 2R is equal to X by 2. So we can easily find how is VM related to V. Anvita, is it understood?
Yes, sir.
Yeah, the power part also is clear. No? This is a simple application. This we can easily calculate. Okay, let's see this question. This question, so far what we have done in case of current, exactly same thing is valid for voltage. That also is nothing but a similar term. So can we find RMS value of V in time interval 0 to T by 4? What will be the RMS value of voltage between time 0 to T by 4? Khyati?
Yes, sir.
What was the RMS value of voltage between 0 to T by 4? Looks too complicated, is it not? Kathy, how does it look like? It looks easy, not looks easy. Okay, not sure. Okay, what will the value of VRMS? Preetham, can you tell what is the RMS value of V in time interval 0 to T by 4?
0 to T by 4, sir.
No, that's what question is.
Okay, yeah.
This is how it is varying. It's varying linearly from here to 0 to T by 4. What is the value of VRMS?
I did in the normal method using the formula. I got V0 by root 3.
V0 by root 3. We can do calculation also. And if we had done something similar, in case of current, it was equal to I0 by root 3. It will be equal to V0 by root 3. If we can do by using your integration as well. It will come equal to V0 by root 3. And suppose I have to ask here, this also V0. And what will the RMS value between 0 to T? 0 to T by 4 is equal to V0 by root 3. What is the VRMS between 0 to T, Preetham? That also is equal to V0 by root 3. Why is that so? The RMS value 0 to T0 by 4 is V0 by root 3. The maximum is V0 and 0. V by T by 4 to T by 2 also same value. Here also same value. Here also same value. All 4 equal time intervals. RMS value is V0 by root 3. So all put together 0 to T also will be equal to V0 by root 3.